Hello everyone and welcome to the course of 5G Physical Layer by Telcoma Technologies. So in this we are going to discuss about 5G Physical Layer. So the physical layer is the most important in any wireless technology, whether 2G, 3G, 4G or even 5G. The new radio is the term for the air interface of the 5G technology. So this new radio air interface is designed with such good scalability and also with flexibility enough so that it will be able to support the number of users, use cases, number of users, and also it can provide high data rate. So it could be able to support the wide range of frequencies and deployment option. So new radio is designed which will fit all the requirements with such physical layer which is flexible enough. It has ultra lean and forward compatible design. So the 5G new radio will operate in the frequency range like below 1 GHz to 100 of GHz with different deployment options. So there will be more coverage per base station, that means the macro site at the lower frequencies, and limited coverage area per base station which is micro and pico sites, and these are at higher carrier frequencies. So to provide the high service quality and optional reliability, you have licensed spectrum also in 5G. So it has various modulation schemes, waveforms, frame structure, reference signals, multi-antenna transmission, channel coding, etc., so that it can support the various use cases and requirements. Now duplexing. 5G new radio uses existing time division duplex and frequency division duplex transmission and reception techniques. They operate at higher frequency bands. Time division duplex, they offer the flexibility so that it can adjust the uplink and downlink network resources and it can meet the network demands also. Now if we move to the multiplexing modes, new radio has the requirements to operate in different frequency bands with the combination of the different duplexing modes. The main duplexing modes are FDD and TDD. Frequency division duplex utilizes a separate frequency for the downlink and uplink, and time division duplex utilizes a single frequency and alternates the downlink and uplink transmission in time. For 5G, the choice of FDD and TDD is mainly based on the spectrum allocation and frequency band which is chosen. Let's have a look to the FDD. It has a different frequency for uplink and downlink, F1 and F2. Whereas in time division, there is a switch in time and the single frequency. We can see the F1 as a frequency and time is being varied. Supplementary downlink, SDL, it is known as SDL. So this use of SDL is related to providing a capacity boost in the downlink. The frequency range 1427 MHz to 1518 MHz which are made available for this operation, supplementary downlink operation. Both LT and 5G new radio specifications include these bands which resides between these frequencies. Now if the SDL is lower than the primary band, suppose you have a primary band and then you have SDL band also. So if this frequency is lower, then the coverage footprint will be larger and extra coverage cannot be used. Why? Because this is due to the device which needs uplink provide uplink control information. This is SDL. We can see here, this is the uplink and the downlink coverage, the green color bar. Now SDL, this is the main FDD TDD band, NR band, and then F2 is the supplementary downlink band. Supplementary uplink. This also support, new radio also support the supplementary uplink which is known as SUL. Here the primary band provides good downlink and uplink coverage. However, as a result of the power limitations, uplink coverage is actually reduced because the power of the device is less as compared to the base station. This is typically implemented at lower frequency band, and thus the uplink footprint is much greater. This the supplementary uplink. Thank you.